Math here, and this is the 2012 AIME 2 problem 6. Let's have a view of this problem. Let z equal a plus bi be the complex number with modulus z equals phi, and the imaginary part greater than 0, such that the distance between 1 plus 2i times z cubed and z to the fifth is maximized. Let z to the fourth equal c plus di. We want to find c plus d. So let's first write down the information we know. So z is a plus bi. The modulus of z is equal to phi, and then the imaginary part is greater than 0, right? And then such that the distance between this and this is maximized, so we want the distance is just this thing minus z cubed. We want this to be maximized. So how are we going to do this? Well, first we can factor out a modulus of z cubed, and then we get z squared minus 1 plus 2i. We get this. So now we can simplify this a little bit because we know that the modulus of z is equal to phi. So the modulus of z cubed therefore is 125. So this is just 125 times z squared minus 1 plus 2i. Hence it suffices to maximize the modulus, the distance of this. So how can we do this? Well, we have something minus a complex number, so we can maybe look at this geometrically. If we have the complex plane like this, and this is, say, 1 plus 2i, when is the distance going to be maximized? It's simply going to be maximized when they're like opposite, 180 degrees apart. This will produce the maximum distance, right? So doing that, we get that it must be z squared must equal negative 1 minus 2i, and then it can also times some constant k for k greater than or equal to 0. So z squared is equal to negative k minus 2ki, and then what we can do is we know that the modulus of z squared is equal to 45. Therefore we know that root k squared plus 4k squared is equal to root phi k squared, which is equal to k root phi, and this is equal to 25. So solving gives us k is equal to 5 root phi. So hence our complex number is z squared. Leaving the root phi maybe outside, we get root phi. We get root phi times negative phi minus 10i. Negative phi minus 10i. Yep, this is d squared. So now all to define z to the fourth, all we do is square this. Squaring this gives us phi times, well, 25 plus 100i plus minus 100. This is equal to phi times negative 75 plus 100i. This is equal to negative 375 plus 500i. And then we have the requested form. We want to find c plus d, that's 125. And we are done.